So, make sure I can still hear my voice. Yep. Okay. All right. So, I got this drawing here, and it took me, I don't know, a few days to figure it out. I had a different drawing that didn't quite work. So, I'm drawing the 7 stages of the total lunar eclipse of 2019, January 20th, for Manhattan. So, zoom in here. So I had to draw them individually. So there's 7 of them. And so it should, or it does, look like this. So here's the umbra, and then you got 2 in the penumbra, and then you got 2 that are not in it. Um, so here's the times. Uh, so this is what I got drawn here to figure it out. Um, so that pretty much is pretty self-explanatory there. So let's just jump in to AutoCAD and let's just stack these on top of each other. So I got from 8 o'clock to 1 o'clock, or 1:48, which is 5 hours and 12 minutes. So if I stack these suckers on top of each other, let me copy these real quick. I want to do something here after that. Well, I need to show that. So first off, I find this location, which I find on time and date. Where's it at? Right here for January 20th. So I find my local meridian time, which is 12:37. So I base everything off of that time. So 12:37 is it's in my drawing. The 12:37 is 5:12 UTC time, but it's on the 21st. So then I would go to this here, and I would put the sun and this earth here, and then put in the date, and then I would hit this, and then it would give me the distance, and then I draw a circle to find the intersection. Simple. Okay. So I first draw where I get the solstice. So I would copy that because you never uh, rotate the axis. I rotate my location along the axis. So where we at? No, that's another one. So I did the moon there, or when it's a half moon, that's a whole different project. 90 degrees. That's a different project. It came out right though. We're on this one. So, um, so is what I do is I get the solstice and then grab this bad boy, center to here, and then I would rotate. Um, like I'll show you real quick. Rotate. And then it rotates along the axis. So whatever it was like over here, wherever I had it, and then I would rotate it to match that 11, 12, whatever it was, to the center, to that line right here, which is from the center of the sun. So that distance is long way. Divided by 5280. So I get 91 million miles. So alright, we'll undo that real quick. That's how I line it up. And then I can rotate it to um, like on my notes here. Let's see. Not that one. Yeah, for like this one. So from that noon point where it's straight with the sun, I rotated for like 8 o'clock, 119.7 degrees. And then I did that for each one. So I figure out which, 12, the difference between 12:37 and 8:36, like the difference between that, 7 hours and 59 minutes. And then I times that by 15, and then I would get 119.7. So I did do that for all of them. So basically, I'm proving the rotation, tilt, distance, eclipse. I'm proving a lot right here. So we'll just stack these on top and see what we get. See if they fit inside the umbra and penumbra. shouldn't have any overlapping text. So it starts there. So that's the path right there. So then I place that on that point. Okay, so now is what I've got here is the sun. So basically I drew this on the side view and top view. I could probably get rid of the side view. I don't know. I don't know if it really matters. So so you see where they hit right there, they connect and then they line back out. And then so this part in the red is the umbra and the white lines is penumbra. So we'll go to the top view and see where they hit. So that and that is the penumbra, and this is the umbra. So you can see in here, so you can clearly see I got a portion of that one inside there and a portion of that inside there. So I got three in there and a portion and a portion. Okay. Now on this one, it's not in there, but on this one, I kind of do. So it matches uh, pretty much what they got. How they're all, them three are like smushed together. So those three, and then that's like right there. That one seems a little closer, but they're using different. It depends on what site you go to. So it might be 52 on some other site or 53. You know, it might be a few seconds difference. Depend. Depends on. Like I used. Let's see. I used. I closed it, didn't I? I used 37. I used 36. Used 30. Wait, hold on. I can't use that. It's UTC time. Well, I still can. Oh, UTC time. I used 236. 333. And then 441. 512. 543. And 650. And 748. I just discovered this website after I had it drawn, or I probably would have used these numbers, but I mean, it's within a second. But that second might have, made a difference between these, or I don't know. But to me, that's exactly what it does. So what I want to do now, I want to do something to, I want to see the outline of the domes. Like, now let me explode those. And I'm just going to get rid of this down. That's what I'm trying to do. Actually, I probably should have used the one in the middle. Try this one. My bad. Let's do this one. I just want to see where the lines hit without the dome because it kind of covers my view. So move this one. I don't need the times. All right, now move the rest of them there. Actually, I want to color this one. I know that one's like the beginning. That like green. Uh, all right. I'm going to erase these lines here for now. I want to see the path of it. See what it's done. really tell. All I know is it matches this. Oh, so and how I get my information from is from this NASA website. So I go generate, and it gives me the altitude and the azimuth. So this is the altitude, that's the azimuth, and that's the distance. So that's how I do that. So if I go, we'll do one more thing, that's it. Do We'll pick, I don't know, this one right here. So 236. So 236 on the 21st, 236. Two 36. Okay, so that's the distance. So it's 92 and 35. So let me convert kilometers to feet. Paste, copy. All right, now let me get into my view here. All right, so let me do my UCS, NEA, to NEA. I'll draw a line from my location, which is this right there in the center of that white circle. So I'm drawing a line. See it? So I'm gonna paste this line or paste that number. Now, if I was depending, real long or whatever, it should end up right there. So I hit enter, and then I'll draw a line here, and it's right on. Yep, it's came out right. Cool stuff. Ooh.